course, Punchdown tool. Most networks today are built using twisted pair cable of some sort. This cable is usually terminated in wiring closets using a tool known as a punchdown tool. It's called that because that's exactly what the tool does. Punches down the wire into some kind of insulation displacement connector, IDC. There are different types of punchdown tools. The most common is a punchdown tool with replaceable blades for the different types of connectors, either 66 or 110. Figure 1823 shows an example of this type of punchdown tool. IDCs make contact by cutting through or displacing the insulation around a single conductor inside a twisted pair cable as shown in figure 1824. A punchdown tool pushes a conductor between the sides of a V inside an IDC. In this example, a keystone connector allowing a small metal blade inside the connector to make contact with the inner conductor deep inside the wire. A cable stripper snips. A wire crimper, often called a crimper, is a handy tool found in most network technicians' tool bags. Crimpers are primarily used for attaching ends onto different types of network cables via a process known as crimping. Crimping involves using your hands to apply a certain amount of force to press some kind of metal sheet into the inner conductors of a cable. Before you can crimp a connector onto one end, you've got to strip the cable with a type of cable stripper or snip and then properly push the wires into the conductor. Figure 1825 shows what a cable stripper and snip looks like. This particular tool also includes a crimper. Often network technicians will make patch cables with a crimper. They'll take a small piece of category 5E unshielded twisted pair UTP, strip the cable and crimp 2 RJ45 sends onto it to create the cable. Snips will create the type of cable needed to connect a host to a wall jack connection. For example, there are strippers and crimpers for the other types of cable, as well as even specialized crimpers for fiber optic ends. Voltage event recorder power. Alternating current AC is basically the food that PCs and other network devices require in specific amounts to function properly. In the United States, it's normally 110 volts and changes polarity 60 cycles a second, 60 Hertz. These values are referred to as line voltage. Any deviation from these values can create some major problems for your PC or other electronics like death. While we're on the subject, you should know that when a telephone rings, the company central office puts 140 VC on the line to ring that bell. Telephone lines are not always the low voltage devices we think they are. Do all phone systems do this? Even PBX systems within buildings. This is why we have surge protectors. These little saviors use a special electronic circuit that monitors the incoming voltage level and trips a circuit breaker when the voltage reaches critical mass, which is known as over voltage threshold. Even though having a surge protector is definitely better than nothing, they too can fall victim to over voltage events, but they are still cool because even though they're really only somewhat protective, they are multiple outlet strips that give us a lot more places to plug in our stuff. By contrast, a quality voltage event recorder can troubleshoot and even provide preventative maintenance on your entire electrical system, whether it's for a home or huge factory. Although they do big things, they're typically small devices that just plug into a wall and record over time the power quality of a given circuit. You will typically use a voltage event recorder for the following applications: recording voltage. The voltage event recorder monitors and records the supply voltage and checks whether the socket outlet is providing voltage within specifications. Measuring distortion. The device measures frequency and harmonics, and it checks whether your uninterruptible power supply system is functioning correctly. Measuring flicker. It checks the switching loads on lighting systems. Capturing voltage transients. It can help you find intermittent momentary events that may be affecting your equipment. The full waveform is captured with date, time stamp and duration. Environmental monitors. Environmental monitors are designed to monitor the temperature, humidity, power and airflow in an area or in a device. Temperature and humidity are both critical factors in the health of computing equipment. High temperatures lead to CPU overheating, and shortly thereafter systems start rebooting. High humidity cannot be tolerated because it leads to corrosion of electrical parts, followed by shorts and other failures. Low humidity sounds good on paper, but when it comes, static electricity build up in the air, which can fry computer parts if it reaches them. Both of these conditions should be monitored. Temperature and humidity can save you and your precious devices from a total meltdown. By their very nature, networks often include lots of machines placed close together in one of several locations like server rooms. Clearly, these devices all humming along at once generate quite a bit of heat. Just like us, electronics need to breathe, and they're also pretty sensitive to becoming overheated, which is why you'll often need a jacket in a chilly server room. It's also why you need to set up and use temperature monitoring devices. 20 years ago or so, these devices didn't send alerts or give off any kind of alarms. They were just little plastic boxes that had pieces of round graph paper to graph temperature. The paper was good for a month, and for that duration it would just spin around in a circle. As the temperature moved up and down, the pen attached to the temperature coil moved in or out, leaving a circle line around the paper. All of this allowed you to manually monitor the temperature modulation in the server room over time, although intended to alert you when and if there were climate changes. It usually did so after the fact, therefore too late. Today, these temperature humidity systems can provide multiple sensors feeding data to a single control point. Nice. Now we can much more accurately take the temperature in our server rooms dynamically in real time. The central control point is usually equipped with HTTP software that can send alerts and provide alarms via a browser should your server room experience a warming event. Temperature humidity monitors also come in a variety of flavors. They vary in size and the cost and come in hardware or software varieties. The kind you need varies and is based on the size of the room and the number of devices in it. You can even get one that will just monitor your PC's internal heat. What else will indicate you have a temperature problem in your server room? When you install new servers in a rack and you have network instability and other issues all across the servers in the rack, but the power resources and bandwidth have been tested. This would be a good time to check your temperature monitor and verify that the servers are staying cool enough. Another red flag when it comes to environmental issues is a problem that occurs every day at the same time. This could be the time of day when the room temperature reaches the problematic stage. Summary: you need network tools and you need to know how to use them. And I said, you can get your hands on many of them for free, so download them and use them as soon as possible to get the experience you'll need to pass the Comptia Network Plus exam. This chapter covered network scanners, included packet sniffers, IDS and IPS software, and port scanners. I also covered hardware tools, which are rarely free. The good news is that you don't need many of them yourself, but the company that owns all the equipment definitely does. Even though I've used all the tools that I've talked about in this chapter, I don't own most of them personally, only the ones that are free or relatively inexpensive. In the hardware tools section, I covered cable testers, analyzers, certifiers, TDR, OTDRs, and other critical tools that help you test the cables and devices in your network, monitor them and keep them up and running smoothly. So I'm going to leave here today for this video. If you like listening, please consider like, share, subscribing and give me a thumbs up. Thank you.